My name is Xander Soldaat. I've been playing with robots since about 2007. In 2008, I bought my first Mindstorms NXT set. This is when the NXT 2.0 had just come out, I think. And it really sparked my interest because before, with the regular little robots, I always had to mess around with hot glue and screws and what have you. And well, I'm not very good with that kind of stuff. And when I was a kid, I always played with Lego. So for me, it was quite a logical step to buy the Mindstorms NXT. So I became quite involved with writing software for sensors and making the brick do things that it wasn't supposed to do. I was using a programming environment called Robot C, and I was quite unhappy with the lack of support for third-party sensors, and also the ones that I was making myself. So I started writing a suite of drivers that sparked the interest of several manufacturers of sensors, and well, it grew and grew and grew, and I think my sensor suite is now used by almost all of the first Tech Challenge and other robotic competitions in the US. So that's pretty cool. It's like 8,000 teams or something like that. And I'm very heavily involved with Robot C, which is actually a programming environment created by Carnegie Mellon University, the Robotics Institute. And I'm actually currently working on getting Robot C working on the EV3, the Mindstorms EV3, which is the new Mindstorms. So what kind of hacks have I done with the brick? And it's not just the EV3 brick, but also the NXT brick, of course. I like making it do things that you're not supposed to do with it. So a little while back, I had a real problem. I have two dogs, and these two dogs, they like to bark. So what I did was I wanted a way to be able to tell whether my dogs were barking while my wife and I were out. So I built the NXT comes with a nice sound sensor. It was actually the first time I ever used the sound sensor because I've never found another use for it. And I wrote a little program on my PC, and I had a sensor which was able to act like a keyboard. It was a HID sensor. So the NXT connects to the HID sensor connects to your laptop. So with a command line, it would send a tweet. And the tweet would say how many times my dogs had barked in the last minute or in a period of time. And well, the truth was a lot more frightening than we had anticipated. We were out on that first morning that I had activated my Twitter tattle, as I'd call it, and we got like dogs have barked 278 times in the last 3 minutes, and then next message, dogs have barked 208 times in the last 4 minutes. And this went on and on and on for hours while we were out, and we were mortified because, you know, the dogs are barking and the neighbors are hearing it. So yeah, that helped us actually figure out that the dogs were barking. So that was one of the hacks that I made. I also got to test a Wi-Fi sensor for the NXT, and I spent a long time trying to figure out what I was going to do with it because, you know, I couldn't figure it out. But I played with a thing called Splunk. I don't know if you guys are familiar with it. It's for big data mining. So I wanted to have a way to monitor the light, sound, and temperature in my room, in my Lego lair, as my wife likes to call it. It's basically the room where I play with all my robots and my Lego. And so I wrote an SNMP version 1 agent in Robot C that talked to the Wi-Fi sensor. So Splunk would kick off an SNMP get, communicate with my brick, get all the information from the temperature sensor and the light sensor and the sound sensor, and it would plot nice data, and I called my project Little Big Data. And I published all the stuff on my blog and everything else. That's another thing that I do. I run a blog. And it actually got the attention of the guys of Splunk, and they thought it was a really cool thing. So yeah, got to chatting with some of the engineers there. That was kind of cool. So the thing that I think probably got the most hits of any of the hacks that I've done so far was also with one of the first Wi-Fi sensors. Was a very simple web server programmed in again in Robot C, and it was a real nasty hack. I mean, there was so many resets in there. So if it didn't get if it mangled some of the messages, it would just reset the whole device and try again. And what it was able to do is with a simple URL that you could type in your browser, you could make a motor move, and a light would go either green or red or blue. And I had a webcam pointed at it all the time, and I would use Ustream for people so they can actually look and see what they were doing. And I think within 1 week, I had somewhere between 6,000 and 7,000 hits. And there's nothing more annoying than an NXT motor constantly going the whole time. And after a week, I shut it down because it was driving me crazy, right? And but that was probably one of the most fun things that I've done with the NXT, because I had never written a web server before, and I had no idea I was going to accomplish it, and I was really pushing the boundaries of what was possible with the hardware that's in the NXT, because buffer size is very limited, and string size in Robot C is limited to 20 characters. So you can imagine how hard it is to try and make a parser for a HTTP request when you have a header about this size. From if you look at an MSIE HTTP header, it's huge. There's so much crap in there. So it took quite a bit of fiddling. That's why I had so many reset stuff in my actual code, because, well, the program got lost because there'd be so much garbage coming in from the sensor. Couldn't read it quickly enough. So yeah, the code was a total hack, but it worked, and it was stable-ish for about 7 days until I shut it down. And yeah, that was a really fun thing to do. The things that I'm doing now with the EV3, I've been involved since 2010 with the EV3 stuff. I was invited to become part of a small group of adults that would be able to help Lego develop the EV3 program. It wasn't called EV3 back then; it was called Rudolph. And if you actually look at the source code in that I uploaded last night, you'll actually see references to Rudolph in the etc. issue of the Linux OS. It's one of the, I don't know why they didn't get rid of it, because it was supposed to be a secret code name and nobody was allowed to repeat it, but it's still there, which is kind of cool. And so I've been involved with that since 2010. We first got to see the hardware at Lego World here in the Netherlands. I think there was about 30 of us in total, and Mr. Stephen Cannon was there as well. He was still working for Lego back then, and he's the community manager, or was, and so he was really involved in wrangling the adult fans to go help Lego with this new EV3 stuff. So last year we actually started getting the hardware in. We were able to do a couple of things with it. The only problem was that we never got the source code until about a month and a half, 2 months ago. So before that, we were kind of left on our own devices. We had figured out that you can boot the thing from SD card, so we dumped the OS from Flash, put it onto an SD card and managed to make it boot and everything else. And some of us had Python running on it and other things. And just for just for shits and giggles, really, I tried to make a Twitter client on the EV3, and I actually have a Twitter account for my EV3, and it tweeted a couple of things. Unfortunately, I was not able to read out the sensors or anything like that at that stage. But at the moment, John Hansen and I are working very hard. John Hansen is the guy who wrote Bricks CC. He's quite a big person in the Mindstorms community. He's a firmware developer. And him and I are working together to make a userland library that anybody can use to link their Pythons and their Perls and their Luas and all sorts of other things. So with the release of the source code that we did last night, we're really hoping that a lot of people will start getting involved and start really hacking the brick, and using it for things that it was never meant to be used for. Some of the things that we envisioned were using it as a network intrusion device. I mean, you have an innocent-looking robot. You give it, you put it somewhere on a desk or something like that. Nobody's going to suspect that it's running, I don't know, some kind of Wireshark or whatever. I mean, nothing stops. I mean, it's just an ARM9 machine, so make it do whatever you want, right? It runs Linux. So these are some of the things that we would really like to see the community do. And now that the source code is out, the box, the brick is available if you're in the US, and pretty soon it will be available here in Europe as well. And we can't wait to see what you guys will come up with, because I think there's a lot of very smart people here. And I was already talking to some of the guys inside to try and solve some of the issues that I've been having, because I've been working on the input part, the sensors and everything else, and there seems to be a bit of a bug in one of the kernel modules. So what we're really trying to do is make an alternative programming environment that people can use. So that's the hack, I guess, that I've been doing with the EV3. Things that I would really like to do is get the robot C working on it, get all the other programming languages. So yeah, that's basically what I've been doing with the EV3. Yeah, there's not a whole lot else that I've been doing with the EV3. Other than try and promote it on my blog and everything else. So some of the things that I've been doing with the NXT, with hacking, for example, I've created quite a number of sensors. I created a big board for a guy who was using his NXT for artificial intelligence to make a robot that could roam autonomously. It used 8 IR sensors and I think 12 press buttons. And he had no idea how to make something like that. So I hacked together a big sensor platform, I guess, for the NXT. I wrote all the software for it, and he's using it for an NXT powered lawnmower robot. We were all really worried about it because, if nothing's more dangerous than a robot with blades. So that was quite fun. I've also helped develop a number of sensors together with High-Technic Mind Sensors and Dexter Industries. Dexter Industries is a bit of a newcomer to the NXT Mindstorms world. They started a couple of years ago by a guy who was really passionate about robotics and especially NXT. And I helped him develop the GPS sensor, which is kind of cool. It started off with a very rough Arduino-powered sensor. and I helped write the firmware for it because he wasn't comfortable with writing that sort of stuff. So in the beginning, it was a real hacky sensor. I mean, I hot glued all the capacitors onto it to stop it from, breaking off, because it was really nasty looking. But later iterations, we added like a battery, backup battery, and everything else. So it didn't take at least a minute for it to get a lock on all the GPS satellites. And later on, I helped him develop the Wi-Fi sensor that became actually quite popular. It was the first Wi-Fi sensor made for the NXT platform. Later on, 2 more came out. I was involved with the development of all 3. So I helped with debugging the firmware on the actual sensors by using logic analyzers and all the stuff that you need for debugging this kind of stuff. And that's stuff that I really enjoy doing. Is the trying to figure out why something doesn't work. So I can spend hours and hours and hours just analyzing data dumps from all these sensors and everything else, and trying to figure out why something isn't communicating the way it should. Another cool sensor that I had a part in developing was a line following sensor made by a company called Mind Sensors. It's actually a really cool sensor in that it can actually do almost everything for you. It has an array of 8 sensors that can detect a line, and it has a PID controller in there and everything else, and all you need to do is feed the value that comes back out of the sensor into your motor speeds, and it runs. So it takes all of about, I think, maybe 4 lines of code to make a very fast line follower. I put it on my I actually put it on my blog at the time, and it was one of the fastest NXT line followers that were out there, and it was so easy to configure and to use that it was actually banned from several robotics competitions because it made line following too easy. So they actually had to redesign the sensor, remove all that PID stuff, and then it was allowed back into the competition. It was actually Robocop Junior, the rescue part. It uses a line follower to find victims and things like that. So it actually quite a number of robots were banned at one point because they were using it. So that was kind of funny, I thought. So yeah, so I'm really heavily involved with several companies to try and come up with new and exciting sensors for the Mindstorm platform. And I think that in the next year or so, there will be a lot of innovation happening on the EV3 side of things. It's the new EV3 platform is really great because you've got 4 serial ports that you can use to communicate with whatever devices you would like. So I don't think there's any kind of sensor that you can't actually use with the EV3. UART means that you can use a GPS sensor attached to it. There are you can use I2C, which is an industry standard. Okay, the clock is a little slow; it's only 10 kilohertz, but I'm sure somebody's going to figure out how to make that go a little faster. The source code is there, so it's all yours to tinker with. The UART is also allows you to have proper bidirectional communication, which wasn't something that you could do with the NXT. The NXT was on one port; it had an RS-485, but it was like not duplex, but the other one. So you could only communicate. Only one could communicate at the time, which made my web server so incredibly difficult to make as well, because if you got unsolicited data on your serial, everything was garbage. Anything was just, you couldn't do anything with it anymore. So the new EV3 will not have that problem, of course. and it goes up to quite a high speed. It goes up to 400 kilobaud on, or 460 kilobaud on the first two ports, and half that on the third and fourth ports. So there's really no limit to what you can do with that. The chip runs at 300 megahertz. It's a little slower than a Raspberry Pi, but you have such a. I think the power of the EV3 is all the stuff you get around it. It's the ability to prototype very quickly using all the Lego pieces. I've seen some pretty amazing things that people are working on at the moment. That will be revealed in the very near future, that do the most amazing things. I don't know if you guys are familiar with the Lego World. It's actually the biggest Lego event in the world. It's here every year in the Netherlands, and this year there's going to be a massive Lego Mindstorm stand. We're actually going to be close to the door as you come in. It'll be there. It's going to be, I think, several hundred square meters. We're going to have an incredible amount of loads of demos and everything else, and some cool hacks. It's in October. I think it's from the 17th until the 20-something of October, and it's in Utrecht, in the biggest, one of the biggest venues in the Netherlands, actually, for this kind of thing. And I'm actually working on some football playing robots at the moment, also NXT, also EV3 powered, and I'm hoping to have them finished by the time. I'm also working with another guy in Canada who's actually working on artificial intelligence and neural networks and everything else, and we're busy trying to get the neural network kit that he's been working on to make it work on the EV3, which is really kind of cool. And because he's got a whole programming environment around it that makes it really easy to simply click a bunch of neurons together. You give it a couple of parameters. It actually generates C code, which you can just compile and then push to your brick. It works for the NXT right now. It compiles it to Robot C, and Robot C can just you can just copy and paste that into your Robot C integrated development environment. But with the GCC, it opens so many possibilities. It makes it you have so much more memory on the EV3 with the NXT. I mean, you can imagine you can't make a very large neural network if you only have 64K of total RAM, half of which is consumed by your VM. With the EV3, you have 64 megs at your disposal. When the VM is running, or the Lego VM is running, I guess you have a little less. There's a couple of RAM disks, so well, even if you have 50 megs left at the end, that's still a lot of memory to put your neural networks in or whatever. You probably can put more in there than the actual processor can handle. But it opens so many doors to making great things with the new platform, and well, I'm kind of hoping that all this stuff will really take off in fall when it becomes more widely available. Universities start using it, and all this kind of stuff. So those are the hacks that I've been working on, and this concludes my my talk. Are there any questions from people? Yes. Yes. Well, for the NXT, you have two choices. Well, three. You can use analog, which is not very useful for this in this case, but you can use I2C, which is limited to standard, on a standard firmware, it's limited to about 10 kilohertz. Like, it's a pretty slow clock speed. But you can also use RS485 if you like. It's not RS232, but it's RS485. Dexter Industries chose to use I2C because Well, with an update rate of 4 hertz, GPS doesn't really generate all that much data, and if it takes you, I don't know, 20 milliseconds to get all the data across, it's not so bad. So what we did was we have the Atmega on the actual board. It's just run. We just made it with Arduino, really. We used a generic GPS library that we found on the net that communicates with the sensor using just a standard serial object. And there are some things on the actual chip that allow you to calculate or set a particular destination, and it will tell you the angle you need to travel at. So it will tell you, okay, you're getting close to the angle you're supposed to go at, and once it starts reading 0, you know you're headed in the right direction, right? So it can also calculate distance between 2 points. It has a whole bunch of functions that would be well, I guess time-consuming to do on the NXT if you can just have the sensor do all that stuff for you. So yeah, basically what we did was we made a, bluntly speaking, like an RS-232 translator to I2C, with all the stuff in there to make it, a bit more, to add some value to it, I guess. Oh yeah, it can't do anything else. Yes, that's correct. That's correct. The NXT is completely incapable of doing anything other than being a master. It's because all the stuff is actually bit banged. There's no interrupt-driven I2C on the NXT. Well, there is, but it's actually used internally to communicate with the coprocessor, which is on the NXT that does all the motor control and it reads the analog sensor stuff. And that's a high-speed I2C connection. I think it runs at 100 kilohertz. And yeah, the other stuff is all bit banked, and that's why it's so slow. It's only 10 kilohertz. The EV3 does not do I2C any faster because it's actually hard-coded to go no faster than 10 kilohertz. The reason for that is that the ultrasonic sensor that LEGO produced is actually completely incapable of running anything faster than 10 kilohertz. It will just die. It will crash and hang. It also has some other weird oddities that are actually coded for in the kernel modules for the EV3, where there's all sorts of hacks in there that make it possible for the ultrasound sensor to work with the EV3. It doesn't play very nicely with the supposed I2C specifications. Neither does the NXT, in fact. The NXT does not allow clock stretching or anything like that. So if you have a slave that tries to clock stretch, it just crashes the bus. It's completely, it's pretty crap. I don't know off the top of my head if the EV3 allows for clock stretching, but it's also bit banged, so I would say probably not. But it would be good if somebody made that work, of course, and made the speed go a little faster. There's all sorts of things that could use a little improving on the EV3s, but that wouldn't make it necessarily better for, say, the 10 to 14-year-old kid, but would make it much, much better for people like us who like to hack things and make them do things that they weren't supposed to. One of the best things would be an interrupt-driven I2C implementation, of course. I don't know if that's possible. I haven't looked at the hardware closely enough to be able to see. But at the moment, that's all bit banged too, all the I2C stuff. So it uses a standard timer that just ticks every 0.001 millisecond. So yeah. Any other questions? yes, if you make no changes to the firmware, if you create a sensor, like, I mean, this is how companies like High Technic and Mind Sensors and Dexter Industries do their thing. They're making third-party sensors for an existing platform. They're not making any changes to the actual platform themselves, but nothing stops you from creating a sensor for the EV3 platform, creating a block for the graphical programming language for it, and making it work. If you are, yeah, if you want, you can do that. I don't think there's any licensing issues there, at least not that I'm aware of. Mr. Canvins shakes no, so no, you're safe. It's GPL v2. So yeah, you can do with it as you wish. Well, as long as you put all the stuff back in the community, of course. Unless it's for your own use, then you can do whatever you like. So yeah, you can do whatever you like. Any other questions? I would like a more modern Linux OS to run on it. Right now, it's a rather old Armstrong OS. It's running kernel 2.6.33 RC4. It's quite old. It's using an older tool chain. It's Code Sorcery 2009 Q1 203 or something like that. So it's all old stuff. But that's because they started working on this stuff back then. So it is time consuming to continuously upgrade your tool chains and everything else. And they just, then you're working with a moving target because kernel changes. Okay, shit, our modules don't work anymore, or the hardware is now working slightly differently. You got to go through the whole process again. And it's just too time consuming. So they really viewed it as an appliance, like a microwave. I mean, for the kid, the EV3 is no different than how you would perceive a microwave. You're not going to worry about the firmware level on your microwave. As long as it cooks your food, you don't care. For a 14-year-old kid, it doesn't care that it's running 2.6 point whatever. It just wants to know how to make the motors move. So it's, for Lego, it was more important for them to have a working platform for the core market, which was the kids, because the adults will fix all that stuff themselves anyway. I mean, that's why there's NXC. That's why there's the enhanced firmware for the NXT. That's why there's like 35 programming language for the NXT, probably even more if you count some of the more exotic ones. There's Java running on it. There's actually a guy who's almost got all of the Java stuff working on the EV3, and that's going to be published pretty soon. So you'll have like a completely functional Java implementation for the EV3, which is really cool because it uses almost the same API as Lejos, which is the Java implementation for the NXT. And it's got an extremely rich API that is great for it does, like, it has classes for making navigation robots that can you basically tell it, okay, this is the layout of my motors, and this is the kind of sensor that you can use to get your heading. And basically you say, okay, I want to go in that direction at this particular speed. It will calculate all your motor speeds and continuously check whatever sensor it is that you're using for calculating your heading, and it just makes it work. It's this stuff. It allows the developer to focus on the things that are truly important, rather than all the fiddly stuff that you don't want to have to redo every single time you make a robot. If you want to make a football-playing robot, do you want to have to worry about how to control the position of your robot, or do you want to worry about the game, the gameplay that is truly important, that makes the robot play football? This is the kind of stuff that makes the Java implementation for the NXT so incredibly powerful, and that's what's going to make the Java implementation for the EV3 so incredibly powerful. Is you can not have to worry about all this, well, stuff that is not really important. It's the same reason why we program in C and not assembler, because we don't want to have to worry about all the little fiddly bits. I wrote a PWM controller one time in assembler for the parallax propeller, and it was a nightmare because I had to do a long division all in assembler because there was no such opcode, and it took me forever to debug that because it wasn't working at first, of course. No code ever does, but it's really frustrating when you have to deal with trivial stuff when you really want to just focus on the things that are important. So Robot C is another one of those programming languages that takes a lot of that stuff away from you and allows you to focus on the things that are truly important. Of course, I have to plug Robot C because I'm working on it. But Robot C has a built-in debugger that's a lot easier to use than GDB. Well, I think anything's easier to use than GDB, really. It does the debugging on the VM level, so the code runs inside a virtual machine. The virtual machine is the same, or pretty much the same on the Arduino. It's the same on the Lego, the NXT platform. It's the same on the VEX Cortex platform. So you program something in Robot C, it will work on, I think, probably about 5 platforms right now. And with the EV3 coming, it'll probably be about 6. So it makes it extremely powerful for teachers to use. It's meant for an educational platform. It's meant for kids, really. So yeah, I think high-level programming languages are really important, and I would love to see a lot of them on the EV3. Python, I think, is a really important one because Raspberry Pi. I think the power of Raspberry Pi is all the Python modules that are available for it. I would love to see that for the EV3 and take back some of that Raspberry Pi user space. Because I think the power of the EV3 is that you can literally build a robot in 10 minutes, have a robotics platform. Okay, it's going to look a bit crap, but you're going to have to spend a bit more time on it if you want to make it look decent. But you can have a robot with 2 motors and wheels in a matter of minutes. It's really just simply clicking it together. Well, if you're using a Raspberry Pi, yeah, you gotta solder the cables. You gotta have the motor controllers. You have to worry about your power. You're gonna have to make sure that you don't get funny feedback from the power from the motors going back into your Raspberry Pi and frying everything. All this stuff, you don't have to worry about it when you're using the Mindstorm's EV3 or NXT platform. So yeah. I would love to see all those things that make the Raspberry Pi so powerful come to the EV3. Like the web, one of the things that I thought was really cool, and it was also mentioned in Stephen Canvin's presentation yesterday, is the web IDE that allows you to have an actual embedded environment on your Raspberry Pi. I would love to see that on the EV3. I think that would make it really cool. You just plug in a Wi-Fi dongle in there, you start it up, you log in, like the IP address would appear on the screen. You log into it, and all your stuff is put into, I think it's paste bin. It puts all the stuff in, but maybe we can make it work with Dropbox or something else, or Google Drive or whatever. And you wouldn't have to worry. I think it's cloud-powered. I mean, it's all the hype. So why not try and make it work on the EV3? So, any other questions? Oh. I'm actually. I'm for another little while. I'll be in the maker shed or the maker tent or whatever it's called, and we have a whole bunch of hardware. Some of it can actually be disassembled. So bring a screwdriver and a pliers, and you can let loose on some broken NXTs and EV3s that are just waiting to be completely disassembled and played with. We also have a massive box full of Technic Lego and bricks that can be played with, actually programmed and stuff like that. We've sensors and everything else, cables, you name it. You can play and have fun with making a Mindstorm's EV3 robot, and maybe hack something together yourself. I'm only here today. Mr. Stephen Canvan will be there for the rest of the week.